Let's answer this item about chemical kinetics. So here we have CO plus Cl2 forming COCl2. We did experiments with different concentration of CO and then Cl2. These are again the reactants on this reaction, and then we measured the rate given the following concentrations. So after observing this one, we are to determine the rate of the reaction when the concentration of CO is equal to 1.25 molar and then Cl2 is 2.50 molar. So what equation should we use to determine the rate of the reaction given the concentration of our reactants? That's the rate law, obviously. So in this case, the rate is equal to some constant times the concentration of our CO raised to the power of x power, and then times the concentration of Cl2 raised to some y power. So this CO and Cl2, these are the reactants because again, the concentration of the reactants, they affect the rate of the reaction. So before we can determine the rate of this reaction, we need to first identify this variables here. So we have this k, this x, and then y. First, let's determine the x and y here. These are the order of reaction in respect to CO and then Cl2 respectively. So to determine the order of the reaction, of course, we'll base this one on the experimental data. So first, let's determine the order of reaction in respect to carbon monoxide. So here, our focus is on carbon monoxide, so the other reactant must be constant. So in this case, Cl2 is constant on experiment 2 and experiment 3. So we can use this one to focus on carbon monoxide. So here, CO increase its concentration from 0.25 molar to 0.50 molar. So it's doubled. So it increased by a factor of 2. Again, that's raised to some x power equal to the change in the concentration of our, increase the change in the rate of the reaction. That's from 1.97 to 3.94. Let us solve that one. Okay, so again, that's okay from 1.97 to 3.94. 3.94 divided by 1.97, that's 2 times. So in this case, that's equal to 2. So here, if 2 to the power of x is 2, then what is x here? X is obviously 1. So the order of the reaction in respect to CO is equal to 1. So again, this x is equal to 1. How about for our Cl2? So to determine the order of reaction in respect to our Cl2 here, we need to look for the experiment that the other reactant must be controlled. So in this case, CO must remain constant. So in this case, constant CO on our experiment 1 and then experiment 2. So we can use these experiments to determine the order of reaction in respect to Cl2. So in this case, that's from 0.40 to 0.80. That's increased by a factor of 2 raised to some y power equal to the change in the reaction rate. That's from 0.492 to 1.97. Let's solve that one. 1.97 divided by 0.492. That's equal to approximately 4. So in this case, the change in the reaction rate is by a factor of 4. So here, 2 to the power of y is equal to 4. Then what could be y here? Y obviously is equal to 2. So in this case, we have determined the x and y in the equation. So after determining the orders here, we can now determine the constant k on this equation. So let's solve that one. Okay, so to find the constant, we need to use the rate law. Again, that's R, the rate is equal to constant, then the concentration of CO raised to the power of, on this case, x is equal to 1 because this is in first order. And then we have the concentration of Cl2 raised to the power of 2 because this one is a second order reaction. So after that, we'll plug in any value from our data. So here I'll just use the data from experiment 1. So we have here the rate of the reaction that's equal to 0.492. 0.492 molar per second. That's equal to K. We are finding for the K here. And then the concentration of CO, that's 0.25. Again, I'm using the data from experiment 1. That's to the power of 1. Then the concentration of Cl2, which is equal to 0.40 squared. Okay, first let's solve this one first. So I'll just copy this one first. 0.492 molar per second. Okay, then 0.25 to the first power. Okay, so by the way, here we have molar because this is the concentration. So that's 0.25 molar, obviously. And then this one, 0.40 molar squared. So that's equal to, okay, 0.40 squared. So that's 0.40 times 0.40. That's equal to 0.16. So in this case, that's 0.16 molar squared. Next, we are going to, since we are finding for K, okay, let's multiply this one first, 0.25 times 0.16. 0.25, 0.25 times 0.16, that's equal to 0.04. 0.04 molar times molar squared. And then the other side again is still the same, 492 molar per second. I'm finding for the value of K here, so I'll divide both sides by 0.04 molar times molar squared, the same thing, divide both sides, 0.04 molar times molar squared. So obviously this will be cancelled here. So what's left here, I'll put it here. K is equal to this one, 0.492 molar per second over 0.04 molar times molar squared. Now let's divide this one. Let's use the calculator again. 0.492 divided by 0.04, that's equal to 12.3. 12.3, and what's the unit here? That's molar per second divided by molar per molar squared. So of course that's molar per second, since then multiply by the inverse of this one, that's equal to 1 over molar times molar squared. We can cancel this one. What's left is 1 over seconds, then molar squared. So here the constant is equal to 12.31 over second molar squared. Again, that's K is equal to 12.31 over second molar squared. So we have determined the X, the Y, and then the K here. We can now determine the rate of the reaction. So let me erase the writings here. It will take time. Okay. So in this case, we can now use the rate law. So we have the rate is equal to K times the concentration of CO raised to 1, and then the concentration of Cl2 raised to the power of 2. So we can now plug in all the values, the given, and then the determined values, the K, the X, and then the Y. So here we have the rate is equal to the K, the constant here is equal to 12.3, 1 over seconds molar squared. And the next, the concentration of our CO. So here the given is 1.25 molar, and then raised to the power of 1. And then we have the concentration of Cl2 that's equal to 2.50 molar. 2.50 molar raised to the power of 2. So let's solve this first. Let's copy this one, 12.3, 1 over seconds molar squared. And then 1.25 to the power of 1, that's obviously 1.25. And the next, 2.50 squared. Let's use our calculator. That's equal to 2.50 times 2.50. That's equal to 6.25. So this is equal to, okay, 6.25 molar squared. Now let's multiply everything here. That's 12.3 times 1.25 times 6.25. Again, 12.3 times 1.25 times 6.25 is equal to 96.1. Okay, so here the rate is equal to 96.1, and then what's the unit here? So this is cancelled, this is also cancelled. So 1 times m, that's equal to m molar over second. So in this case, the rate is equal to 91.6 molar per second.